All right, so we're in AP Calculus. Today's date is Monday, February 3rd. This is the Unit 8 pretest answers. And this was a purely calculator test, which means I should probably open up my calculator emulator. Wabbit, EMU, File, Open Recent, and TI-A3+. All right, so how do we do these? And I am totally unprepared because I did not look at these for like a whole year. Hopefully I do okay. We have Camp Newton. It has a water tank with 1,200 gallons of water. So there's our start amount. Let's go ahead and label it in our notes. So that is our start amount. And our start time is time equals 0. That's nice. And we have a good time interval. Pumped into, so that means we have a positive rate. Pumped or removed, that means it's a negative rate. And I'm immediately going to type these into my calculator and immediately have y3 is set equal to the positive minus the negative. That's the, whenever on our speech sheet we have a positive and negative, we do positive minus negative. So type these in real quick. 95 square root of that x, end the parenthesis, and I'm going to say sine of t divided by 6, and then square it. So yeah, the square happens on the outside, not the inside on our calculators.
Yeah, I think I also had this calculator for the pretest. So.
Okay. So we know how to do it now. Geo, you're good. Stego, good. Arrow, good. And then type in the next one, 275 sine of t, where is it? X divided by 3. And then square it at the very end. So those are our two functions, and then the third function is going to be y1 minus y2. So vars right, enter 1 minus vars right, enter 2, y1 minus y2. And I don't really need to graph anything. I'm just going to get out of this. So second mode to quit out of this. Is the amount of water in the tank increasing at time is equal to 15? So we need to figure out what the positive minus the negative one is at 15. So I can just say, in this case, what is y3 of 15? I'm just plugging in 15. Why am I doing that? So I'm looking at the amount. And if I'm ever asking if this one thing is increasing or decreasing, I'm taking the derivative of the amount and figuring out if that derivative is positive or negative. So the derivative of an amount is just a rate, and these are rates that are being given to us. So I'm really plugging in 15 into these rates. So technically what I'm doing is I'm saying W of t, or W of 15 rather, W of 15 minus capital R of 15. Is this a positive or a negative number? And the way that I can do that is using my y3 function. So I said vars right, enter 3, my y3 of 15, and put that in parentheses and hit enter, and that is a negative 121. I don't care what the number is. I just care that it's negative. Yeah, Gio?
Do you also track that from the positive, from the starting amount?
So I don't care about the starting amount because I started with 1,000,000 gallons, but is it increasing or decreasing from that 1,000,000 gallons? It doesn't matter what the starting amount, it just cares if it's going up or down. Yeah, good question. Yeah, so this is a negative amount, so I'll say that's less than 0 because our answer was negative 121. And therefore we can conclude, and I'll write this.
So for that, you did the positive rate minus the negative rate, and you plugged in 15 for t.
Exactly, yes. Yeah, so we can say here, no, the water amount is, or I can say the amount of water, that sounds weird to say. The amount of water is decreasing. Why? Because W of 15 minus R of 15 is less than 0. So as long as you had the word no, or it's decreasing, and then you have the rationale as well, I think it's 1 point. Let's go check our key here. So this was from 2005, Form B. If this seemed hard, it was because it was from a Form B question. Part A, you get 1 point if you get the answer with reason. So come back here. And that was just 1 point there, with answer with reason out of 1 point. To the nearest whole number, how many gallons of water are in the tank at time is equal to 18. So I'm looking for an amount, a final amount. So final amount, I'm doing start plus change is equal to end. So start. Our start amount is 1,200. 1,200. And then I'm going to add the change. So I'm adding the integral between 0 and 18 because I'm going all the way to time is equal to 18. It's always the start time down here, and the start time we already determined was 0. And I'm doing the total change, so W minus R. So I'm going to say capital W of t minus capital R of t, and then technically all of that dt, but I'm going to kind of abbreviate that. And that should be my answer. I just need to type this in now. So here we go. And again, this is our y3 function, so this is going to be 1,200 plus math 9, the integral of vars right, enter 3, our y3 function with respect to x from 0 to 18, and hit enter. And because we already added the 1,200, we just write whatever we got here. And it's taken its sweet time to do that, but let's check the key. What are we supposed to get? We're supposed to get 1,309.788, and then we round that to 1,310. So 1,309, hey, there it is, 0.788. We got the right answer. So I can say the exact integral is 1,309.788. So our final answer that we should be saying here is 1,310 gallons. And we'll box that, because we round up to the nearest whole number, and that happens a lot. So reading is really important.
It's very important.
Being able to know that you are supposed to be rounding. So how do we score ourselves? Limits, integrand, answer. So you get 1 point if you got 0 and 18. Give yourself 1 point. 1 point if you wrote capital W of t minus R of t. Actually, I don't think I would get my point because I was not formal about it. Always be formal when you're writing out your answers. I should have written all this dt, otherwise I would have gotten a point taken off. So plus 1 now for the correct integrand, and then 1 point for the 1,310. So that was out of 3 points. Part C. I'm looking for the absolute minimum. Whenever I'm doing a max or a min, I'm doing a table of the start plus change values. So, and then show the work that leads to your conclusion will be the table. Let's go ahead and set up our table really quickly here. So we have column. Oop. Make you straight. It'll work. We have our t values. We have our start. We have our change. I'm realizing we're kind of running out of room here, so I'm going to move that line over. Change, and that's going to be equal to our end values. Let me move this bar to the right-ish. I can grab all of this and move it a little bit more, then move that bar back. Cool. So what t values should we check? We always check the beginning and the end, 0 and 18. We also check all of the relative extremas, or if you don't know what's a relative extrema, you can just do the CVs. Where does this thing equal 0? And unfortunately, the only way that I know to do that is with a graph. So we have to figure out where does this cross the graph. That's the t values that I should be putting here. So if you need to make a note to yourself, say, these are the middle values right here is where you cross the axis. So you have to graph this. So I need to have the correct window now. So between 0 and 18, 0, enter, 18, enter, and then zoom 0. Oh, no, stop, on. Because if I come back here to my, quit. If I come back here to my y equals, I'm graphing all of y1 and y2. I only want to graph y3. I don't care about y1 and y2 individually. I just care about y3. So zoom 0 again, and now it will have the correct graph. We'll figure out where it does cross that t-axis. So go. What we should have found, let's see here. We should have found that it crosses both at 6.495 and 12.7 or 12.975. How did we get those though? If it will show me my work. So right there it crosses at 6.495, and right there it crosses at 12.7 or 12.975. I don't know, I keep saying that. How do you find those values? You do second trace to calculate the zeros. So I hit 2, and I know that it's going to be 6.495. So I'm going to guess here 1. I'm going to guess the end boundary is 10, and any value in between, like 2, will give me the exact value of 6.495. You may indeed throw out the other value. Go. 6.495, rounding correctly. So come back here. 6.495. And then the other one, I'm just going to write down 12.975. 12.975. And then let me talk about what Arrow just said. We're looking for a minimum. The definition of a minimum is where the derivative goes from a negative to a positive. So I'm going from a negative to a positive at 6.495. That's a good value to choose. It's preceded by negative area, so it could be a minimum. But this one is preceded by positive area, aka it goes from a positive derivative to a negative derivative, that is the definition of a maximum. We can throw out 12.975. That is not going to be a possibility. So let me put a screenshot of this calculator in here so I can talk about it a little bit. So we can say in here that this value right here, let's use maybe yellow. This value right, it's still kind of hard to see. Maybe black would look better, I don't know. This value right here is a relative minimum. This value right here is a relative maximum. So we can kind of exclude that point. We're not looking for it. Our start value for our table, we always start at 1,200. So 1,200, 1,200, 1,200, 1,200, and I'm going to go ahead and scribble that one out because we don't need it. Oh my gosh, you're right. You can log it. I'm scribbling out the one that's the maximum that I don't want. Again, I can scribble out this change right here because it's going to be the integral between 0 and 0, which is nothing. So the end value at the start is the start, 1,200. We already calculated this last one right here. We calculated that back here. We did 1,200 plus the integral between 0 and 18. So this is plus the integral from 0 to 18 of, I'm just going to say capital W minus capital R. And that was 1,309.788. That was from part B. The only thing that we need to calculate is right here and find the most or the smallest value. So far, this one is winning for the smallest value. This is going to be the integral between 0 and 6.495 of capital W minus capital R. Let's do that on our calculator. So let's get out of this. I'm going to do 1,200 plus math 9 of our vars right, enter 3, our y3 function with respect to x from 0 to 6.495, 6.495. I wonder if the microphone can pick up the crackling of the knuckles. We'll have to check the video later. And we get, I mean, I can just look at the key to make it faster, 525. So I come back here, probably, yeah, it rounds it, so 525.242. 525.242. And it's just looking for the time. So let's write out our full answer now. It's obviously that one is the smallest value. So our answer here is we say t equals 6.495 is the time for the minimum amount of water with 525.242 gallons. I always write the time and the amount. That way, no matter what the question is answering, I will get the points. Just get in the habit of doing both of them. All right, we are now on to scoring C. I should not forget about that. C is worth 3 points. Arrow, check this out. So your question is now answered. See how that's a plural? You do need to at least write down 12.975, but you do not need to write down the 1697. That's how they score it. That's how you play the game. So you do need the interior critical points. I know that this point was a maximum, not a minimum, but you at least need to write down that t value. That is a t value that is the critical value. So you get 1 point if you did both of these 2 points, plus 1 right there. The other point that you get is the amount of water is least. So 1 point for saying, hey, yeah, it's 6.495, and then 1 point for somehow explaining your answer. It says your analysis. So the table is our analysis. So plus 1 if you have the table. Just writing a table with no values is not enough for an analysis. That analysis point only kicks in if you have an answer and you have to have the answer before you get a point from the table. That was out of 3 points. And then finally part D. This one was extra credit, I believe, in the key, right? Yeah, because it was kind of difficult. Do I have the key up here? Yeah, this was out of 0 points. I said it was extra credit. How do you do it, though? So we're looking for when the tank is going to become empty. So we know that this, so we're starting at 18. So we need to start with 1,309 gallons. That's how much we had at time is equal to 18. So you can either enter it as this function right here, which represents 1,309.788, or you can just write down 1,309.788. I'm going to do that. So 1,309.788. That was my start amount. I'm always doing start plus change, right? Start plus change. And my change now, it should be a negative amount, and it's still removed at a constant rate of capital R. So my integral is going to be something to something of capital R of t dt. Well, where do I start now? I start at time is equal to 18. And when do I end? I don't know. I don't know when the tank is going to become empty. And it tells you just find K. Just use K and K. So if I say, when does my start plus change equal 0? That's when it becomes empty. And there's my final equation.
So you don't really have to solve anything.
You just need to set it up, exactly. And then how does the key say it? It says, when does the value of, oh, they just add 1,310 to both sides. So what they essentially said was, wait, that doesn't, oh, because it's a negative rate. So this is now a negative direction. So it's really confusing on whether you should think of this as a minus or a positive, minus or plus. But it does make sense because, yes, this is a negative rate. So it does need to be a minus sign in terms of just the mathematics, because when this is a big number, that means a big negative number. So I was incorrect. I should have had a negative sign because it is a negative rate. Whenever you do a positive and a negative rate and you combine those two, you can always have that as a plus. But whenever you're strictly talking about a negative rate, it does need to be a minus. So good area to make to show you that example. Totally made that on purpose. You could have gotten 2 extra credit points. 1 if you had the correct limits, just saying from 18 to K, and 1 point if you got everything else. So that one technically could have been out of 2, but it's going to be out of 0 for extra credit. So again, 1 point right there, and 1 point for everything else. Number 2. Ah, yes, the sewage problem. So we have our entering amount. So this is our positive rate. Everyone write down a plus symbol. That's our positive rate. And our negative rate is just a constant amount, 645. And again, whenever you have a positive and a negative rate, always subtract them. Even if this isn't a function, it technically is a function. Even if it doesn't look like a function, subtract it. So let me come up with my 2 functions. Let's clear out of all of these. So if I come back up here, let's enter in 850 plus 715 cosine of, it's going to be pi, so second to the power of to get pi, times t to the power of 2 divided by 9. All right, so I have my function entered, and my second function is going to be my y1 minus 645. So bars right, enter, enter. My y1 minus 645. So this y2 function now represents the total amount, my positive minus my negative. Usually it's our y3 function, but I'm not going to just enter in 645 for y2 and then do y2 minus, or y1 minus y2. It's just too much work. So my y2 function represents the positive minus the negative rate now. Everyone understands why I'm graphing, or why I'm making an equation for the second? All right, so I'm going to go ahead and preemptively hide my y1 because I know I'm eventually going to have to graph this. Our window, I'll preemptively set that as well. 0 to 4, 0, enter, 4, enter, and I'll hit zoom 0 and let this graph in the background while I talk some more. Okay, so how many gallons enter the sewage tank in that interval? Well, I'm only talking about E. I'm not talking about this 645 yet. So if it's just talking about entering, I'm just saying, and I don't even care about the start amount, which there isn't any start amount. It says it's empty, so I'm going to say that's my start amount. My start amount is 0. So I'm just doing the integral here from 0 to 4, because those are the bounds that I'm talking about, of my entering function, capital E of t dt. And I just do that on my calculator. So my graph is ready. I can use that in a sec. So here we go. Yes.
We got a really high score on the pretest. Do we have to do the fix-up?
Nope, you can leave it, but you didn't get 100. Did you get 100%?
I think I got a lot of the extra credit. And it's like,
Balanced out?
yeah.
Okay, then you don't have to. You only have to do the fix-up if you want to get 100% on the pretest. You should still do it for the extra practice, maybe. Just keep it fresh, right? The integral of my y1 function, that's what is my capital E. So bars right, enter 1. My y1 function with respect to x from 0 to 4. And go. 3,981. 3,981.022. And let's read the rest of this. So we found the amount to enter, but it says round to the nearest gallon. So if I'm rounding this to the nearest gallon, then my final answer is just 3,981 gallons of sewage. Yummy. Let's come down here to the the scoring guide. This is from, it doesn't say the year. I don't know what year this is, but it's question 1 on, oh, it's from a BC calculus test too. There it is. 3,981, integral and answer, 1 point each. So 1 point if you have all of this integral set up, that's +1. And 1 point if you rounded correctly, you got 3,981. It doesn't matter if you had the units. Units are not scored here. Part B, and usually, so whether or not to get points on the units, you can tell if it says use correct units or something like that, then it's going to be giving you a point for that. Part B, when is the sewage the greatest? This is looking for a maximum value, so that means I'm making a table of start plus change values. Let's go ahead and set up our table using my electronic ruler. That sounds way fancier than I'm just using this line tool. My t values, my start plus change is equal to my end. All right, what t values should we always check? The start and the end, 0 and 4. And then the next thing, where do you cross the t-axis? And for that, that's why I preemptively made my graph. Well, it looks like this is 1, 2, about 2.2 and about 3.5. How do we find those exact values? I do second trace to calculate those zeros, so 2. I'm going to guess that value is between 0 and 3. I'm going to just guess 1. That's a really bad guess, but it'll give me the same answer regardless. 2.309. So 2.309. And we learned from our last question that even if we don't like that because it's a minimum and we're looking for a maximum, still write down that critical value. That one looks to be between 3 and 4. So I'm going to say second trace to calculate the 0, hit 2, between 3, enter, 4, enter. What's between there? 3.5. And I get 3.559. 3.559. What is our start value for all of them? Well, it says that the tank was empty. So 0, 0, 0, 0, 0, plus, 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 the integral, and that one's 0, 0, so let's just cancel that out preemptively, and that's 0, because 0 plus 0 is 0. Let's go ahead and eliminate one of these right now. I don't want to do too much work. So if I come back to my graph, I'm looking for a maximum. The definition of maximum is where the f prime, or this rate that I'm talking about, goes from a positive to a negative amount. So that's a maximum right there. So let me annotate this. I can write this in my notes. Shoink. Let's paste it right there. Go, computer, go. I have my graph. And come back here to my pen tool. That right there is a relative max, maybe not the absolute max, and this is a relative minimum. So I'm going to exclude this third value because that's a minimum. We're looking for a maximum, the greatest value. All right, so this is going to be the integral between 0 and 2.309. This is going to be the integral between 0 and 4. We found the integral between 0 and 4. That's 3,981.022 plus 0 is itself. So I have capital, oh, that's not right though, is it? Because we're doing capital of E of t minus 645. So I actually need to do this with my y2 function. So I can't just rewrite it down. Darn. Thought I could save some work. So I'm going to come back here and say math 9 of my vars right enter 2 function, which is just subtracting that 645, with respect to x from 0 to 4. And let's just look at the key to save some time. That's 1,401. 1401.022. 1,401.022. Did my calculator catch up to me? There it is. And then I have to do the same exact thing with the bounds from 0 to 2.309, and I'm not going to do that because we know how to do that, and that's 1,637. 1,637 .178. 0.178. Yes, question, go.
How did you get the first, you see the top, like, was it the, like, number 2, the first top one? Why couldn't you use the second one? The last one, like, the
Yeah,
fourth?
great question. So this goes from a negative height to a positive height. The definition of f prime goes from a negative to a positive is a minimum.
And you can tell that if you look at the problem, it's asking for when it's the greatest. But like for the 4, like you know you had like because we did it on the first one above it, like the very very top.
The first one above it.
So the 645. This. why couldn't we use this?
So a slightly different equation because it has -645.
Oh, like why didn't we just copy that down? Is that the question? Oh yeah, so this is the integral of E, how much is entering. But this is the total amount, so the total amount not only has to have the entering, but also subtract the negative equation. And the negative rate is the 645. So it's going to be the integral of E minus 645, which is, again, slightly different. There is a shortcut for doing it, because you can just say minus the integral from 0 to 4 of 645, and we know how to do that. That's 4 times 645. So if I actually did 3,981 minus 4 times 645, I would get 1,401.022. Notice how it's 0.022 also. Yeah, good question. And I was talking too fast, so I should have slowed down. But there it is. Again, we don't need to recalculate that. I mean, you'll do it on the actual test, but I don't need to show that, I don't think, unless you guys want me to. No. All right. So yeah, there's the answer. When is it the maximum? Well, there it is. 1,637 is the biggest number in that list of 3 numbers. So let's come down here and type in our answer. Always have your answer written out. Don't just circle things, because it makes it very clear to AP graders you know what you're doing if you write out your answer. At time t is equal to 2.309, the amount of sewage is at a maximum value of 1,637.178 gallons. Oh, we would have gotten a point taken off. Someone tell me why, and you can get your extra credit point.
The time isn't
Nope, I wouldn't have gotten a point taken off from that, but I should probably put the time there to be better about that. No, not quite. What am I in per hour?
round
There it is. Yeah, I
Wait,
would have.
what about your DT?
Yeah, so in this table, it does not have to be formal, but it does say very clearly to the nearest gallon, and I wrote 1,637.178, and I did not round. So if it tells you to round and you don't round, you lose a point. Come on, let me edit you. I just want to double click you. I don't want to move. There we go. Oh my gosh, my computer's dying. There it is. It's because I'm recording at the same time. Normally my computer can handle this. All right, and then how to score yourself. You get, oh my gosh, 4 points. So 1 point if you somehow use 645. This is not the clearest key, but yeah, you have to somehow use 645. And we did that because in both of these integrals, and I should have written this should be capital E minus 645 to just kind of show you what I'm doing. If you somehow wrote minus 645, or if your answer uses 645, you get a point. So it's very clear that I got a point from using 645 there. Oh, that's not quite what it means, does it? This is just saying find those t values. So a better way of saying that is, did you find these correct t values? Because if you did, you clearly were finding these values where it crossed the x or the t axis. So I'm going to say if you found those 2 values, give yourself a point. Not if you use the 645 over there. That's my bad. Did you write down 2.309 anywhere on your paper? Well, I did, right there. Did you find the correct amount of sewage for that t value? Did you write down 1,637? And we did. And finally, did you write up your conclusion? There's our conclusion down there. That is indeed the answer. So out of 4 points. And on to part C. Ooh, we have a cost associated, which is that. So we just need to multiply our cost by the amount of sewage. Cost times amount is the total cost. So how do we do that? Well, we take the integral now from 0 to 4 still, because our bounds are still of 0 to 4. The amount of sewage that enters the tank is the thing that we're going to be multiplying by, because it says that enters a tank is being multiplied by that. So I'm going to say capital E of t is going to be multiplied by this 0.15 minus 0.02 t, all that stuff, dt. And we need to round to the nearest dollar, so don't make that mistake again, Mr. Sindel. and then we'll just calculate our answer. So how do we do that? We can just type it in right here in the calculator. I don't need to go to the y equals. You can just do it here. So math 9. That's going to be vars right, enter 1. Again, y1 is our e of t function. y2 is our e of t minus 645. So y1 times, in parentheses, 0.15 minus 0.02 x, in parentheses. Okay, so there's our function with respect to x from 0 to 4. And there's our price. And it's going to take forever to do it, so let's just find out what the price should have been. 474.320. 424.320, but that's not the answer because we need to round. And I did write that down correctly. Calculator, did you catch up to me yet? There it is. Ooh. Oh yeah, they rounded correctly. So they rounded this to the nearest cent, 320. And the final answer is 424 bucks. Which is kind of cool. Like if you think of yourself as a contractor, like how much should I charge this person? You're going to charge them 424 bucks for how much sewage? For 1,637 gallons of sewage.
You should probably do more.
Yeah, we should really charge more. The minus 0.02 T, you get a slight discount for every gallon that you have to dispose of. How to score yourself for part C. 1 point for integrand, 1 for limits, 1 for answer. So 1 point if you wrote all of this down. I should write this in red. 1 point if you wrote all of that stuff down. 1 point if you wrote between 0 and 4. Really? Just the limits? That's an easy point. So 1 point if you just wrote from 0 to 4. Easy peasy point there. And then 1 point for saying 424. That's red. I want to make it a different color so I know that it's not the scoring guide. Sure, yellow. And then finally, number 3. Yeah, pollutant. A lot of these gross things. We have some sewage and then some pollutant. We're given a rate. This is already the positive minus the negative. This is the total amount. I don't have any equations to combine. And it tells us our start amount. Our start amount is 50 gallons at time is equal to 0, so that's our start. And it tells us some information that's going to be useful later, that the lake is considered to be safe when you have 40 gallons or less. So let's enter this into our calculator. We're going to need it. Y equals clear, clear. In our y1 function, we're going to do 1 minus 3 second natural log to do e to the power of, and then it's going to be negative 0.2, and then I do square root of x, and then we're good. All right, let's get out of that. Clear. And then coming back to the question, I'm taking a look at the amount of pollutant, and is that increasing or decreasing? Whenever I'm talking about increasing or decreasing, it's always taking the derivative of whatever I was talking about. So the derivative of the amount. Well, the derivative of the amount is the rate, and we were given an equation for rate, so really we just need to plug in 9 into our rate and we're done. So it's asking, what is P prime of 9? Is that a positive or a negative value? If it's positive, it's increasing. So I come back over here and I say vars, right, enter, enter. My y1 function of 9 is a negative amount. So I come back up here and say, yeah, that was 0. And then we can have our answer. So we can say, no, it's not increasing. It is decreasing. Why? Because P prime of 9 is less than 0.
And if there was a negative rate, you subtract the positive rate with the negative rate.
Yeah, positive. Exactly, yes. Yeah, good insight. How to score yourself. Let's come down here to number 3. This is from 2009. Again, Form B. Man, Mr. Snell is mean. He gives you all the hard problems from Form B instead of Form A. You get 1 point if you got the right answer and the right reasoning. And they got exactly the same thing that we got on our calculator, negative 6.646. So I come back over here and say, yep, give yourself 1 point because we said decreasing because of the correct reasoning out of 1 point. For part B, what values of t will it be at a minimum? Whenever I'm doing minimum or maximum, I'm doing a table of the start plus change values. Let's get my table set up. Table, column. Oh, why did it go diagonal like that? There it goes. Okay. Probably could hold shift and make that faster. Our t values, if we could let in Claire, please. We're doing start plus the change. And that's going to equal to the end. All right, what times do we always check the start and the end? We don't have an end, we just have a start. So we definitely need to check time is equal to 0. We don't have an end, so you can cross that guy off. We are on number 3 right now, yes.
Okay, can I just go over that because I kind of just skipped that one because my calculator didn't want to work.
Perfect. Do it on your new version, though.
Or can I just do it with pen?
Or that works too. And then you can do it again a third time. Okay, so now we need to find, since we don't have an end, we need to find all the points where this crosses the t-axis. So we need to graph this thing. And we don't know what interval we should graph it on. I'm just going to guess 0 to 50. If we don't see anywhere, I'm going to go from 0 to 100. So my window is going to be from 0 to 50. And I'm going to hit zoom 0. It might be a crazy graph. If we don't know our bounds, just make a big bound and see what happens. Go, go. And it looks like, does it cross? Does it cross? Does it cross? Hey, it crosses right there. I'm going to guess that's roughly 25-ish, maybe 30-ish. So I'm going to make my new bounds from 0 to 30. Actually, I can probably just find that value right now. I'm gonna guess it's about 30. So how do I find that? Second trace to calculate the 0, hit 2, between 0 and 40. Do giant bounds and just guess 30. How close was Mr. Sindel? I guessed 30 and it was, whoa! That was a good guess. 30.174. 30.174. It's unimpressive to you guys. You're like, oh, you've done this problem 3 times. I was like, yes, but it was a year ago. It doesn't count. So we know that the start value was 50. So, by the way, we're done with our t values. We have all of our critical values, all of our not really criticals, our CVs, that's critical values. Relative extremas, where it crosses the axis. That's the values that we care about. We don't have to do end values, so we're done. Start is always 50. It tells us that in the problem. 50, 50 plus the change. So plus the integral from 0 to 0. Okay, that guy's gone. That's always 0. So the end values there is clearly going to be 50. Because 50 plus 0 is 50. This one is going to be a little bit more interesting, though. It's going to be the integral between 0 and 30.174 of p prime of t, capital P prime of t, dt. So how do I find that guy? Well, it's going to be, get out of this, I'm going to do math 9, the integral of vars right, enter my y1 function with respect to x from 0 to 30.174. And I'm just going to go to the key because it'll be faster. And it tells me what is going on here. Oh, there it is. Got 30.174, and we're left as 5 natural log of 3. Isn't this oh, dang. I might need to change this. This was a non-calculator question. How do I know that? No, this was a calculator question. It was question 2. Question 1 and 2 are always calculator. So I don't know why they're leaving it in this weird form. They should just show us the decimal. It's not like, if you kids have a calculator, you're going to use it. We got negative 14.896, and then I'm going to add that to 50, right? I forgot to do plus 50. Plus 50, and I get 35.104. 35.104. We're looking for the minimum. Which one is smaller? 50 or 35.104, and it's clearly 35.104. Let's type in our answer now. All right, so at t is equal to 30.174, is it minutes, hours, what are we in here? Days. 30.174 days, the pollutant is at a minimum value of 35.104 gallons. Done. And done. All right, so how do we score this guy? For part B, you get 1 point for setting p prime is equal to 0. 1 point if you somehow wrote that. We did it in this form. We said we found the critical value, or the relative extrema. So we clearly set that p prime equals 0 to get this thing. Essentially, we're saying, where does it cross the axis? That's the point that you're getting right here. 1 point if you solve and you actually get that value. So we actually get 2 points right there because we solved and we set it equal to 0. And then I'm guessing another point for answer and justification. Oh, it doesn't even say you need the right answer here. That's a weird way to score this. This must be a really old 2002. Yeah, it's 18 years old.
This is as old as us.
Oh yeah.
Yeah, dang, that's crazy. Okay, so and you get 1 point for the justification, 1 point for the table. You did not have to have the right answer, apparently, for this question. Interesting. Part C. Is it safe when it's at its minimum? Well, it's safe if it's below 40 gallons, and 35 in my book is less than 40. So we come down here. Okay, so now you need to actually calculate this thing. So we didn't have to calculate it before, but now you get points for calculating it. That's why we didn't have to get the answer correct last time. And if you come to the key, you actually have to, see, integrand limits, you actually have to do the calculation now. So we get the points for having the limits and the integrand all up here. So our points are coming from a different spot now. How many points you get? 1 point for the limits, 1 point for the integrand, and 1 point for the answer and justification, I believe is what it said, right? Conclusion based on the integral. So our conclusion down here, we can type it in. We can say, yes, it is safe because 35.104 happens to be less than 40. And all of our points came from up above, so that one was out of 3 points. That one was also out of 3 points. All right, part D. An investigator, oh gosh, those guys scare me, is coming in, and he is using a tangent line approximation, because this guy doesn't know calculus. He can only go back to lines. He can't do curves. So he uses the tangent line approximation. Every single time that I see these words, tangent line approximation, I'm thinking of y minus blank is equal to blank times x minus blank. That is what it means to be a tangent line approximation. Write it down. Y minus blank is equal to blank times x minus blank. There's your tangent line approximation at t is equal to 0, which is a horrible model in my opinion, but it'll work. So that means it's not really an x, right? It's a t. Let's come back here and change this to, oh, come on, computer, you got this. Change this back to a t. Oh my gosh, it's going so slow. Okay, t, and then the t value that I'm choosing is 0. When I plug in p of 0, what's happening? Well, I know that the amount of pollutant that I started with was is 40, right? The start amount is, 50. Ugh. 50 is the start amount. That means 50 is my y value, my start amount. And then finally, I need to figure out what value goes in there. So I need to take the derivative at time is equal to 0. And hey, we have the derivative. The derivative is p prime of t, and there it is. So I just have to plug in 0 into that formula, and that will be my slope. So right here, this is coming from p prime of 0. I'm just plugging that in. In my calculator, that looks like this. Vars, right. And to enter my y1 function of 0. What happens? And I get -2, a nice simple number, -2. So there's my model. What does it want us to do? At what time t does this model predict the lake becomes safe? So again, it's not the most accurate model because it's a line instead of a curve, but let's go ahead and rearrange this model. So I'm going to add 50 to both sides, and this is going to be y. I guess it should be p instead of y, huh? Let's make this a little bit more formal and say capital P. Oh my gosh, computer, do your thing. Come on. All you have to do is delete something. Now you need to write something. So capital P. So now I have P of t, I guess, is equal to -2 times t is -2t. And then I need to add 50 to both sides, so plus 50 to make this t slightly curvy. There's our model. And when does this model become safe? So when does this amount of pollutant become 40 or less, right? That's what it means to become safe. So I come back down here and say, okay, well, oh, you already solved it?
I mean, I looked at it and figured that you need to subtract 10 from 50 to get 40, and then
Oh.
get to 10, so you do -2 times 5 to get to -10.
That is very correct. So if I subtract, I get -10 is equal to -2t, and then finally t is equal to 5. So at time is equal to 5 days, it predicts that the lake will become safe. But again, I love pointing out that lines are not very good at approximating things. Curves are much, much better, and we have calculus as a tool to use those curves.
So that means because that's the way it's actually being measured, the lake is probably safe.
The model, well, it becomes safe sometime because we know it has a minimum.
It's like the first month.
Oh yeah, so the model
5
predicts
years
the
dangerous.
lake will be safe after 5 days. But I love these problems because, like, if you really take a step back and think about it, these are the real, maybe not the exact equations, but like you can model it with an equation, which is what Claire and Ben are going to be doing, and then you can use calculus, you can use all these math tools and figure out cool things. Like, okay, let's just use a line, and then if we use a line, we can say, hey, go swimming after 5 days. That's kind of important information to tell people when they're allowed to go swimming, right? Now let's do the multiple choice. We have 4 minutes left of class.
Really crazy, this calculation. problem. People would have probably died from that.
Yeah, you should definitely use calculus over algebra 1 if you have the ability to use calculus. I agree. We have a continuous function, and we need to find b. So I'm going to set these two equal to each other, plugging in the suspect point. So it's going to be 5 squared plus 5b is equal to 5. I set this side equal to 5. This side is 5. And then solving, right? So then I have the ability to divide everything by 5. And I get, this is 25 divided by 5 is 5 plus b. I'm going to subtract 1. And I really have that equal to 0. Wait, I should be adding 1 to the other side. That would be faster.
Why you have
Well, right now I have this equation, right? I just divided everything by 5.
Why can't you s squared?
Because there's already 5. There's 5 each of them.
Let me back up and show this problem the long way. So I have x squared plus bx is equal to x, and then from there I'm plugging in 5, so I have 5 squared plus 5b is equal to 5, and then I'm going to simplify this to 25 plus 5b is equal to 5, and then from here subtract 25 on both sides, and I get 5b is equal to negative 20, and then divide everything by 5, and b is equal to negative 4. Number 5. For what values is this decreasing? What is the definition of decreasing? It's where f prime less than 0. Very good. So I need to find f prime. So taking the derivative, I get 15 plus 12x minus 3x squared, and I need to set that bad boy equal to 0. Let's divide everything by 3. Divide both sides of the equation by 3. If I do that, I get 5 plus 4x minus x squared is equal to 0. And now I'm going to multiply everything by negative 1 because I don't like having a negative there. Now that's going to become a positive x squared, a negative 4x, and a negative 5 being set equal to 0. But remember that we factored out a negative, and that is going to affect our answer, so be wary. It'll maybe flip your answer. So from here, I'm going to do x minus 5x plus 1. In fact, if I factored it all out, I really factored out a negative 5 out there. There's a full factored form is set equal to 0. And then where do I have my possible, or where are my CVs? My CVs happen.
Yeah, I feel like it was 3.
Because you divided by 3.
Yeah, you can divide 12 or 3 by 5. Right.
I do not know what I was doing there. Yeah, this is a negative 3, sorry.
But does it even need to be?
It doesn't matter what the number is. The thing that matters is that it is a negative. Yeah, please log those. This is a negative 3. Yeah, so coming back over here, our critical values happen at negative 1 and positive 5. And let's figure out where this is positive and negative. And I'm using the full factored form or plugging into the original derivative, either way. So when I plug in, what's the easiest value? I like 0. If I plug in 0, 0 minus 5 is negative. 0 plus 1 is positive. And then there's this negative out here that also affects your answer. So a negative times a positive is a positive. And because these are both to the power of 1, it's going to flip to a negative and flip to a negative. So where is it decreasing? Less than 1, greater than 5. What says less than 1, greater than 5? It is D. We have 1 minute and 10 seconds left of class. Number 6, for the function that, what is the approximation of f of 0.1 using the tangent line? Okay, tangent line. Whenever you see tangent line, you're doing y minus box is equal to box times x minus box. And we're using 0 for x. 0 for x right there. So 0. Y is 1. And what is f prime? Well, we plug in 0 into f prime, and I get negative 2. And then I have to plug in 0.1 for x, and then let's do that on this next line. So I have y minus 1 is equal to negative 2 times 0.1 minus 0, which is just 0.1. So negative 2 times 0.1 is negative 0.2, and then I add 1 to that, I get 0.8. Correct answer is C. Again, I have 25 seconds left. I will finish doing the recording later.
Go back to number 5 for
Yes.
like 2 seconds. I got C. Are you sure that it's negative 1 and not negative 5? You know, the
I am quite sure, yes.
Okay. No, never mind. You're good. I got it.
All right, you found your mistake?
Yeah. I just said, like, we're gonna be-
All right, you guys are dismissed. I'll finish this in a sec. For number 7, you're going to be using Taxman because I have a bunch of stuff happening. So my U is going to be the inner of, okay, this is powerhouse. Okay, this looks the hardest bit. So E house, the inner of E house is x to the power of 4. X to the power of 4. My Taxman knocking on the front door is x to the power of 3. The derivative of that U that I just found is 4x to the power of 3. That means I'm going to pay Taxman. The x to the powers of 3 cancel out, so 1/4. So my new integral after paying Taxman is the definite integral between 0 and 1 of 1/4, there it is, being paid, e to the x to the 4, dx. And the antiderivative of E house is just E house, so this is just 1/4 e to the x to the 4th, and then evaluation bar between 0 and 1. All right, so when we plug in 0, be careful because that is still a number. It's not just 0. So let's do the whole thing. So when I plug in 1, this is going to be 1/4. This is going to be factored out. Let's not worry about him for now. Let's just worry about this problem right here. The 1/4 is being factored out of the entire problem. This is going to be e to the 1 to the 4 minus e to the 0 to the 4th. All right, so 1 to the 4th is just 1. So e to the 1 is just e. And 0 to the 4th is 0, e to the 0 is 1, so this is e minus 1, and then I have that 1/4 being still factored out. And I could multiply it back in and distribute, but I don't need to because the answer is A. And our final problem for pretest 8 is number 8. A particle is moving with a velocity right there, and it has a start. So this is the, I'll write this down, this is the start position, and that is at time 1. So I'm doing the, I need to find the total position. So I have to take the antiderivative of velocity to get to position. So this is going to be the velocity not from 0, but from 1 to 7. Those are our bounds, from 1 to 7 of this velocity equation. So 4 minus, wait, not 7. I don't know what I'm writing there. From 1 to 2. There's the end time. From 1 to 2. There you go, Mr. Snell. And I'm going to add 7 because start plus change. So 7 plus the integral of 4 minus 6t squared. All that stuff dt. Again, this came from start plus change. This is our change here. All right, so when I take the antiderivative, this is going to go 4t minus, and then this is going to go up a power, so it's 6t to the power of 3, and then, I don't know why I'm writing it so far over, 6t to the power of 3, divide down by that 3, evaluation bar for this whole thing from 1 to 2. Don't forget about the 7 that's still being added to all of this guy right here. All right, let's simplify this to just 2t to the power of 3. And evaluation bar, okay, so bringing down that 7. 7 plus, when I plug in 4, or sorry, plug in 2, it's 4 times 2 is 8, minus 2 to the power of 3 is 8, 8 times 2 is 16. 16, and then I'm going to subtract what happens when I plug in 1. 1 to the power of 3 is 1. 1 times 2 is 2. And then, oh, wait a second. That's 2 over there. I forgot to plug in the 1 over here, so it's 4 minus that 2. Let's do some more mental math. 8 minus 16 is negative 8. 4 minus 2 is 2, so minus the 2, add on the 7. 7 minus 8 is negative 1. Negative 1 minus 2 is negative 3. And it looks like the answer is C. All right, that concludes Calculus Pretest 8.